All right, we're going to talk about these different special definitions relating to triangles. And this is kind of cool, but you have to understand the definition, and then you have to understand theorems or properties related to them. So the first thing I want to point out is a perpendicular bisector. Perpendicular bisectors are perpendicular, obviously, meaning 90 degrees, and they bisect the lines. So what are the perpendicular bisectors here? Well, they're going to be, let's find the midpoint for each one of these sides. I'm just kind of roughly estimating. There's the midpoint for that side. Again, I'm roughly estimating. There's the midpoint for that side. And that looks like about the midpoint for that side. To bisect it, or that's bisecting, and the fact that they're perpendicular means that they what? They're 90, make like a 90 degree angle with that point. So there's the perpendicular bisector for that. You understand? Because it's perpendicular and it bisects it. Does that make sense? That's what perpendicular bisector means. Here's the perpendicular bisector for this line. It's perpendicular and it bisects it. This is not the best of triangles. See, those two sides are equal. And where's the perpendicular bisector here? It doesn't quite look like I put that in the middle, does it? This point should probably be, it looks like I'm a little bit off. Maybe right there. Mm-hmm. The perpendicular bisector would be right here. Because this, it doesn't really matter. You can draw it as far as you want. They're just lines. But those are perpendicular bisectors, okay? In any triangle, if you take the three perpendicular bisectors of the three sides, guess what they're going to do? They're going to meet at one point. And guess what that point's called? That's called the circumcenter. Doesn't matter what triangle you draw them on. The three perpendicular bisectors are always going to meet at a point which is called the circumcenter. And not only that, but look at this little extra property here. The circumcenter is equidistant from all three of the vertices, meaning the distance between the vertex, that distance, and that distance, and that distance are all the same. Mm-hmm. That's why we draw. That's why you'll see them draw those pictures in. So let me make that picture a little bit clearer. So this distance right here is equal to this distance right here, which is equal to that distance right there. So I'm going to put an X there, an X there, and an X there. So you can see that all three of those lines are the same distance, because that's what a circumcenter is. That's the definition of a circumcenter, and that's a theorem that comes from the circumcenter. So let's do a problem now relating to it. All right, so let's try this problem. It says, it's telling you right here that M is the circumcenter of GHI of that triangle. It's the circumcenter. Well, what does circumcenter mean?
Perpendicular bisector.
It means where all the perpendicular bisectors meet. So there's one perpendicular bisector, there's another, and there's another. See how those are all perpendicular bisectors, which means this is equal to this. Do you see what I'm writing in? This is equal to this, and this is equal to this. Aha! So what does that mean? Let's start writing what we know. What do we know? If this is 31, what else is 31?
The other side is 31.
This has to be 31.
Mm-hmm.
So that's J, that's JH.
What's the difference between one line and two lines?
What's the difference between one line and two lines? Well, these two lines means that those are equal to each other, but not equal to anything else.
There's no difference. It's
Don't use the same lines. Don't use one line, because that means that they're all equal.
Yeah. Okay, if there was like another one, it'd be like...
Correct. Yeah. So if this is 30 here, what else is 30?
The other side.
That has to be 30.
Yeah.
Got it?
Yeah, I get it.
No. What else do we know?
That line MK is 23. Which means that...
MK is 23, but does that help us necessarily with anything yet?
No.
Not yet. So let's see what else this helps us with. We know, I'm going to use a different color. These lines all have to be equal to each other, right? those green lines are equal to each other. Why? Why do I know those green lines have to be equal to each other? I'm circling it up there because we know that the circumcenter is equidistant from the vertices. And see, here's my H, G, and I are all vertices. So I know, what do I know? Did they tell me 14? What's 14? All right, so see this right here? See where they told us 14? What's that going to help us with? If that's 14 and this is 31 and this is a right triangle, what can I do?
Oh, you do 14 squared.
Yeah, Pythagorean theorem, exactly.
Yeah, 14 squared plus x squared equals 31
So
squared.
see, what we're doing is we're pulling from all of the things that we've learned in all of our years of mathematics and geometry.
Wait, what is the
It's this is a right triangle, right? And we know 14 squared plus 31 squared equals whatever this, we'll call that D, equals D squared, because it's a right triangle. See the right triangle in there? So 14, let's solve that. And solving this gives you that D is approximately 34.0, rounding it to 1 decimal point. So if D is 34.0, then so is all of those green lines. All of those green lines are equal to approximately 34. And then you can work backward to find the other lines, because if this is 34, for example, right here, that's a right angle. You know that 34 squared equals 23 squared plus whatever, we'll call that x, whatever x is squared. And I would recommend leaving what you had here, like keeping that in your memory and using that exact number to find them, because it'll just be more exact and you won't have a rounding error. So the answer there, if you solve that algebra, approximately 25, again that's a rounding, but 25.0 to show that I did round it. So that's 25, so is this. Now what else do I still need? Now you can find this distance here. I'll change colors to purple. You can find that distance there by using 30 and 34, and we'll call that y. So y squared plus 30 squared equals 34 squared. And then solving that, and you get y equals 16 there. So should have found all of my answers, and you can just match them up to those 5 things that they're looking for there. The next thing is called angle bisectors, and angle bisectors also have a very cool property. They all meet at the same place. So what does it mean to be an angle bisector? Well, it means that it literally bisects the angle. So what does it mean to bisect the angle? It means cut the angle in half. So tell me, does that look like it bisects that angle? Where? Right about there maybe? All right, I'm just roughly, all right, let's do this angle. Where does it look like it bisects? Right about there? Okay, you can draw them as far out as you want. It doesn't really matter, right? And how about this one over here? I'm starting on the vertex. Whoa, look at that. Where do they all meet?
The middle.
They all meet at the
midpoint.
Incenter. That's called the incenter. That point is called the incenter. What is an incenter? I'm glad you asked. An incenter is equidistant. Look at what I've written here. It's equidistant from all the sides. Well, what does that mean, to be equidistant from a side? What's the distance between this point and, let's say, this side right here? This side here. What's the distance between that point and the side? What does distance mean? How do I find the distance between a point and a line? What do I have to draw in order to find the distance between a point and a line? I have to draw a
line down the middle.
perpendicular. I have to draw a line that's perpendicular to it. What's the distance between this point right here and this line right here? It's this. This is the distance right there. What do I mean? I draw a line that's perpendicular to it. Do you understand what I'm saying? So I can erase this part of it now. Okay, so that's that distance. What's the distance between this point and this line on the bottom? Do the same thing. Start on that line and draw. Is this the distance? Would it be there? No, where's the distance? Where do I have to go? I have to go when it's perpendicular. Right?
Mm-hmm.
Does it look like that's about perpendicular?
No.
It kind of looks like that's perpendicular to me. Does that look like it's roughly perpendicular to you?
Perpendicular.
Perpendicular meaning that purple line and that black line are at a right angle.
Oh.
Let's try this last side, this side on the left. Let's draw a line to it. Let's draw the distance. Is that the distance? Is that the shortest distance to the line right there? Is that the shortest distance? No, what's the shortest distance? Right about there. How do I know that's the shortest distance? Because that's a right angle. That's to find, if you wanted to find the distance between a point and a line, what's the distance between a point and a line? You don't just draw any old line there. This is not the distance. The distance is the shortest. The shortest means the short distance between a point and a line means the shortest distance between the point and the line. You understand? And how do you know it's the shortest distance? Because it is a right angle. This is a geometric property that I'm telling you right now. Okay? So, this is why this is kind of a confusing concept, because it tells you that the incenter is equidistant from all the sides. Well, what's the distance between a point and a line or a side? It's the shortest distance, which is perpendicular to it. Okay? So what do I know about these three purple lines?
They're the same distance.
They're all the same distance, because that's what equidistant means. So let's try a problem.
Oh, way to go.
All right, so let's try this.
We'll do this.
It's telling you that V is the incenter. And notice they've already done some nice things. They've already drawn my... Oh, see what they did here? They drew that those purple lines are what?
The angle bisectors.
Those purple lines, they're not the angle bisectors. What are the purple lines? They're what are called the altitudes. They're the distance from that point to each side. That's what the distance is. How do I know they're the distance? Because they put the right angle in here. That tells us it's the distance. What's the distance from PQ to the point V? It's the line VS. Okay? So what do we know about those three purple lines?
They're all equal to each other.
Yeah, and why do I know that? Because it told us that was the incenter, and so that's why we know those have to be equal to each other. Understand? What else do we know about these angles in here?
That those are equal to each other.
We know these are equal to each other. Why do I know that?
Because they're just...
Because the definition of incenter is that it's made by angle bisectors. That's what I know. So this angle right here is equal to that angle right there, and this angle here is equal to that angle there. Got it? So what are these? Let me fix this. So let's zoom in on this a little bit. So again, this line and this line and this line, those are all equal to each other. And we also know that this angle is equal to each other. Those two angles are equal.
Yeah.
These two angles are equal to each other. And these two angles here are equal to each other. So now let's put our values in and see what we can do. QT is 5. VU is 7. So we know all of those are 7. 7, 7, and 7, because those are all equal to each other. And PV is 29. So let's find everything that we can find here. Well, we know that this is a right triangle. And so we can use Pythagorean's theorem to find, I'll color code this. We're going to use Pythagorean's theorem to find this red line right here. Pythagorean's theorem would say, if I call that, let's call that x, the distance of the red line. Pythagorean's theorem says that 5 squared plus 7 squared equals x squared, right? Because that's across from that 90-degree angle, so that's the bigger side. X is the bigger side in that triangle. So we can solve that. All right, so that x is approximately 8.6. Now let's do another one. I'll do this in blue. Let's find this line down here.
Wait, so QV would be 8.6.
QV is 8.6. Let's find this line down here. Is that the biggest line or one of the smaller lines?
A smaller line.
It's a smaller line. Let's call that y. Y squared plus 7 squared equals 29 squared. So when I solve that equation,
We don't need P.
I get y equals 28.1 approximately.
But we don't need P.
That's good to know. So 28.1. So let's see what else we can find. So
I get it.
now we can't really find this line. We can't find that line, and we can't find this line because we don't have enough information.
Yeah.
I don't think. But we can find this line. That's going to be the same as y, 28.1,
Yeah.
and we can find this line up here. That line is the same as 5 because of similar triangles that we have in our drawing there. All right, and then there's a couple other things you're going to learn next. I'm not going to go into this video, but here's the next thing: medians. Medians. If you draw medians for all the sides, then you will get you will find the centroid. They meet at a place called the centroid, and there's properties for centroids. And the other thing is altitudes. If you draw altitudes of sides, if you draw the altitudes to the different sides, so like these are your altitudes. Altitudes go right down at right angles. If you draw the right angles down, they all meet at the same place as well. Well, I didn't draw those very well, but if you drew the 3 altitudes, they would all 3 meet at the same place as well.
Here, drop the